September 2, 1945. Tokyo Bay. An unnamed Japanese admiral stands on the deck of the battleship Nagato, watching stone-faced representatives of his government prepare to board the American battleship Missouri. Around him, the bay swarms with vessels, more than 200 ships flying the stars and stripes. The Missouri looms across the water, her gray hull massive, her lines modern. She was commissioned at the Brooklyn Navy Yard just last year. Commissioned in 1944. Built, launched, completed, and sailed halfway across the world, all while Japan's empire collapsed. The admiral's eyes scan the horizon. Everywhere he looks, American steel, fleet carriers, battleships, cruisers, destroyers, submarines, supply ships, hospital ships, landing craft. The largest assembly of naval power ever concentrated in one place. His own ship Nagato was launched at Kure Naval Yard in 1919, 26 years ago. She served as Vice Admiral Yamamoto Isoroka's flagship during the attack on Pearl Harbor. That morning, nearly 4 years passed when Japan's 6 carriers struck the American Pacific Fleet at dawn. That morning, when everything seemed possible. The admiral remembers the intelligence briefings in late 1941. The assessments of American industrial capacity. The confident predictions about American shipbuilding. The laughter when junior officers suggested America might replace its losses quickly. Americans build automobiles, one captain had said, smirking. Not warships. Another had added, their shipyards are commercial operations. Slow. Inefficient. It will take them years to recover from what we're about to do. The admiral looks again at the Missouri. At the carriers on the horizon. At the endless rows of destroyers. 3 years. That's how long it took. Not years to recover. 3 years to build a fleet that dwarfed anything the Imperial Japanese Navy ever possessed. He closes his eyes. Somewhere in his memory he can still hear the laughter. Rewind to autumn 1941. Imperial Japanese Navy Headquarters, Tokyo. A conference room filled with officers in crisp uniforms, cigarette smoke rising toward ceiling fans. On the table, intelligence reports, reconnaissance photographs, assessment documents. The subject, American naval shipbuilding capacity. Captain Minoru Genda spreads photographs across the table. Aerial reconnaissance of American shipyards. Newport News in Virginia. Mare Island in California. Brooklyn Navy Yard in New York. The Americans have expanded their facilities, Genda reports. Government investment in private yards. New slipways. Additional cranes. An older admiral waves his hand dismissively. Preparations that began too late. Even if they started today, how long to build a carrier? 3 years? 4? The Americans completed Yorktown in 1937, another officer notes. But that was peacetime construction. In war with resource constraints, competing priorities. He shrugs. The officers examine photographs of American yards. Compared to Kure to Yokosuka to Sasebo. Japan's great naval arsenals. The American facilities look almost quaint. Commercial. Built for merchant ships and the occasional warship, not the sustained production of a modern battle fleet. Their workforce is civilian, someone observes. Union workers. They'll strike for higher wages. Slow production with labor disputes. Knowing nods around the table. Japan's naval yards, by contrast, represent the pinnacle of shipbuilding art. At Kure, where the mighty Yamato was built, craftsmen spend years perfecting each vessel. Every weld inspected. Every plate measured to tolerances that border on obsessive. The result, ships of unmatched quality. Yamato herself, the largest battleship ever constructed, took nearly 4 years from keel laying to commissioning. Her sister ship Musashi currently nears completion at Mitsubishi's Nagasaki yard. Together they represent the ultimate expression of naval power, 72,000 tons each, armed with 18-inch guns that can strike enemy ships from beyond their ability to return fire. Quality takes time. Excellence cannot be rushed. The Americans, building quickly, will inevitably sacrifice quality. This is the Japanese assessment. This is what every officer in this room believes. And their designs, another captain adds. The Essex-class carriers they're building, we have the specifications. Adequate perhaps, but no match for our Shokaku class. Our Zuikaku and Shokaku are superior in every respect. More agreement. The mathematics seem irrefutable. Japan possesses 10 fleet carriers. The Americans have 7, and 3 of those are converted from other hulls inferior designs. Japan has numerical superiority, qualitative superiority, and most important, time to consolidate its conquests before American production can gear up. By the time they build enough ships to challenge us, the older admiral concludes we'll have fortified every island from the Kuriles to the Solomon Islands. They'll break themselves against our defenses. Only one man in Tokyo harbors doubts. Hes not in this room. Admiral Isoroku Yamamoto sits in his quarters aboard the flagship Nagato anchored in Hiroshima Bay. Hes 57 years old, one of Japan's most celebrated naval officers and increasingly isolated in his views. On his desk reports about the deteriorating relationship with America. Oil embargoes, frozen assets, the noose tightening. Yamamoto knows what's coming. Has been planning for it, the attack that will, he hopes, buy Japan the time it needs. 6 carriers striking Pearl Harbor at dawn, a knockout blow, cripple the American Pacific Fleet before war even begins. But Yamamoto has no illusions about what follows. He spent years in America. First as a student at Harvard in 1919 to 1921, studying English and oil. Then as naval attaché in Washington during the early 1920s, when American industry hummed with post-war prosperity. He remembers walking through Ford's River Rouge plant outside Detroit. Assembly lines stretching as far as he could see. A new Model T rolling off the line every 45 seconds. The speed, the efficiency, the sheer scale. He remembers standing in Texas oil fields watching derricks pump crude from beneath the earth, an endless supply powering American growth. These memories haunt him now. Anyone who has seen the factories in Detroit and the oil fields in Texas, has told colleagues repeatedly, knows that Japan lacks the national power for a naval race with America. His warnings fall on deaf ears. The militarists who control Japan's government dismiss his concerns. The army wants war with China. The navy wants dominance in the Pacific. And Yamamoto, the cautious moderate, finds himself planning the very attack he opposes. The irony isn't lost on him. But even Yamamoto, even the one Japanese admiral who truly understands American industrial might, makes a crucial oversight. He speaks of Detroit. He speaks of Texas oil. He emphasizes American automotive production, American petroleum resources, American manufacturing capacity. He never mentions American shipyards, not because he doesn't know they exist, but because, like his colleagues, he cannot quite imagine what they're capable of. Has seen mass production. He understands its power. But warships aren't automobiles. You can't stamp them out on assembly lines. Theory. Complex, sophisticated, requiring precision and skill. Even Yamamoto, who knows better than anyone, doesn't grasp what's about to happen. The American shipbuilding industry isn't sleeping. It's been preparing. December 7, 1941, 7:55 a.m., Hawaii time. Commander Mitsuo Fuchida leads 183 aircraft in the first wave over Oahu. Below him, Battleship Roe sits peacefully at anchor. Perfect targets. Tora, Tora, Tora. He radios back to the carriers. Torpedo bombers sweep low over the harbor. Dive bombers plunge from above. Horizontal bombers release their payloads from altitude. For 90 minutes, Pearl Harbor burns. The Americans never saw it coming. When the smoke clears, the damage assessment seems catastrophic. Arizona sunk 1177 dead. Oklahoma, Capsized West Virginia sunk at moorings. California sunk at moorings. Nevada beached to prevent sinking. Tennessee damaged. Maryland damaged. Pennsylvania damaged. 8 battleships struck. 4 sunk. The others damaged. The American battle line, the core of Pacific naval power, effectively eliminated. In Tokyo, celebration. In Washington, shock. Across America, rage. Japanese planners had predicted the Americans would need years to recover. The battleship was still in 1941 considered the ultimate measure of naval strength. Carriers were important, certainly. Pearl Harbor just proved that. But battleships anchored fleet strength. Japan had sunk or damaged 8 of them in a single morning. What the attack missed, however, would prove more significant than what it hit. 3 American fleet carriers, Enterprise, Lexington, and Saratoga, were at sea during the attack. They survived. So did the submarine base. So did the fuel storage tanks holding millions of gallons of oil. And most important, though no one in Tokyo quite grasped this yet, the attack didn't touch the mainland. Pearl Harbor's repair facilities were damaged but functional. And back in the continental United States, hundreds of shipyards continued operating, expanded, government-financed, already building. At Newport News Shipbuilding in Virginia, the carrier Hornet neared completion. At the same yard, the battleship Indiana and 6 Essex-class carriers were already under contract. At Brooklyn Navy Yard, workers were installing the keel for the Iowa-class battleship Missouri. At Bethlehem's Fore River Yard in Massachusetts, 4 Essex-class carriers were on order. At New York Shipbuilding in New Jersey, 13 Cleveland-class cruisers were under construction. The Japanese had struck the fleet. They hadn't touched the means to replace it. Washington, D.C., Navy Department Building. Late December, 1941. The mood is grim. Admirals and officials huddle over charts and reports taking stock. The losses at Pearl Harbor dominate every conversation. But Admiral Ernest J. King, soon to be named Commander-in-Chief of the U.S. Fleet, is already looking forward. "What do we have?" he asks. "What's building?" His staff presents the inventory: carriers currently in service. Enterprise Operational Pacific Lexington, Operational Pacific Saratoga, Operational Pacific Yorktown, Operational Atlantic Wasp, Operational Atlantic Ranger, Operational Atlantic Hornet. Fitting out at Norfolk will commission January 1942. Carriers under construction. Essex Keel, laid April 1941 at Newport News. Plus 5 more Essex-class ordered, plus numerous escort carriers, battleships under construction. North Carolina-class, 2 ships nearly complete. South Dakota-class, 4 ships in various stages. Iowa-class, 4 ships ordered. Cruisers, destroyers, submarines, dozens in various stages of completion. King studies the numbers. The losses are severe, but the pipeline is full. More importantly, the infrastructure exists to accelerate production. The Two-Ocean Navy Act, signed by President Roosevelt in July 1940, had already triggered massive expansion. The Navy Department had invested over $229 million in private shipyards, upgrading facilities, installing new equipment, expanding capacity. These improvements were just coming online when Pearl Harbor struck. Newport News Shipbuilding, Virginia. 7 major slipways. Government investment, $21.6 million. Under construction battleship. Indiana carrier, Hornet, plus multiple new contracts. Workforce, expanding toward 30,000. Bethlehem, Fore River, Massachusetts, expanded from 7 to 10. Major building ways. Government investment, $21.1 million. New machine shop devoted entirely to turret fabrication. New welding facilities, X-ray equipment, boring mills, lathes, hammerhead crane, with 120-ton lifting capacity. New York Shipbuilding, New Jersey, 5 slipways, plus new middle yard under construction. Government investment, $20.3 million. Specializing in cruisers. Battleship South Dakota, under construction. Brooklyn Navy Yard, New York. 2 superdocks. Government investment, $71 million. Workforce expanding towards 71,000. Iowa-class battleships and Essex-class carriers assigned, plus dozens more. Bath Iron Works in Maine. Federal Shipbuilding in New Jersey. Mare Island in California. Puget Sound in Washington. And smaller yards building escorts, submarines, landing craft. The Japanese had calculated that America couldn't replace its losses for years. They were about to discover their mistake. Newport News, Virginia, January 1943. At Shipway 10, a massive gray hull sits between towering cranes. Workers swarm over her, thousands of them welding, riveting, installing equipment. Chaise 872 feet long, disping 7,000 tons, and chaise, already been launched. USS Yorktown, second ship of the Essex class, Blaze, named for the carrier lost at Midway 7 months earlier. On February 15, 1943, Captain Joseph J. Jocko Clark walks down the dock for his first look at his new command. Clark is 49 years old, part Cherokee, a fighter pilot who earned his wings in 1925. Hes tough, ambitious, and possessed of a motto that defines his approach to everything. Get things done yesterday, tomorrow may be too late. He stops at the dock's edge and stares up at the carrier's flight deck towering above him. This is his ship. This is his command. And he has exactly 2 months to get her ready. The official commissioning date is set for April 15, 1943. The yard has warned that the schedule might slip. Too aggressive, too much work, remaining too many variables. Clark looks at the date, looks at the ship, makes a decision. We will meet it, he tells his officers. We will commission on April 15th, and we will beat Essex to Pearl Harbor. It sounds impossible. The first-in-class Essex had already commissioned on December 31, 1942. 6 weeks ago. Chaise preparing for her shakedown cruise. Clark's ship is still being fitted out, still incomplete. But Clark isn't interested in impossible. Hes interested in yesterday. Within days, Hes reorganized the entire operation. 4,000 of the yard's 31,000 workers are reassigned to Yorktown, pulled from other projects concentrated on this single vessel. Clark lobbies yard management for materials. When supplies are slow to arrive, he diverts them from other ships. Later, when asked about this, an officer from Essex will suspect a lot of dishonest things were done to get things provided for the Yorktown. Clark makes no apologies. He orders ammunition loaded directly from railroad flat cars, a prohibited procedure that bypasses normal safety checks. He puts the crew to work painting the hull when the yard can't meet his schedule. He even assigns junior officers to chip rust and paint, shattering an ancient naval taboo about officers doing enlisted work. At least one lieutenant requests a transfer rather than pick up a paintbrush. Clark denies it. The workers respond to his intensity. Welders work double shifts. Electricians string the 250 miles of cable and wire needed for the ship's systems. Machinists install the Curtiss turbines that will drive the 4 propeller shafts. Fitters mount the aircraft elevators, the catapults, the arresting gear. Everything happens simultaneously. Organized chaos. Captain Donald Duncan of Essex, a friend and Naval Academy classmate, shares information about his own ship's fitting out. The 2 captains trade notes, coordinate, learn from each other's experiences. Duncan's ship had encountered problems. Clark makes adjustments to avoid them. But Clark doesn't just want to learn. He wants to win. The competition becomes legendary. Beat the Essex becomes Yorktown's unofficial motto. 3 months earlier, on January 21, 1943, Yorktown had been launched. Eleanor Roosevelt served as sponsor. She stood on the platform, champagne bottle in hand, waiting for the ceremonial moment. Then the ship moved. Several minutes before schedule, while speeches were still underway, the 27,000-ton hull shifted on its launching ways. The great carrier groaned and began sliding toward the water. The First Lady, veteran of dozens of ship christenings, seized the bottle with both hands and smashed it against the moving hull. Champagne sprayed. The ship continued its slide. The crowd erupted in cheers. Everyone agreed. This ship was in a hurry. The crew gave her a nickname that would stick: Ship in a Hurry. Now, 2 months later, Clark is making good on that promise. April 15, 1943 arrives. The Yorktown sits at the dock, still crawling, with workers making final adjustments. Paint barely dry. Systems still being tested. But chaise ready. At 1400 hours, Captain Clark reads his orders and officially places USS Yorktown in commission. The ceremony is brief. No time for lengthy speeches. The ship has a war to fight. 9 days later, she departs for shakedown training. Less than 3 months after that, on July 1, 1943, USS Yorktown drops anchor at Pearl Harbor. She beat Essex to the Pacific by 3 weeks. George W. Anderson, Yorktown's navigator, sums up his captain: Jocko had tremendous drive. He always wanted to be first. He was very competitive. But Clark's personal drive is just one small piece of a much larger story. Because while Yorktown was being fitted out at Newport News, 3 other Essex-class carriers were nearing completion at other yards. And behind them more were building. Many more. Raw. Veers. A common misconception about American warship production in World War II. People imagine Henry Ford-style assembly lines, ships rolling off production like automobiles, mass manufacturing on an unprecedented scale. The reality was far more sophisticated. Warships couldn't be built like cars. They couldn't be stamped from templates or assembled from identical parts. Each was too complex, too large, too specialized. Consider the Essex-class carrier: length 8,772 feet, displacement 27,000 tons. Aircraft capacity 96 planes. Crew 600 men. Cable and wiring 250 miles. Turbine machinery 4 sets each, requiring precision machining. Armor plate, tons of it each piece. Custom fitted systems: electrical, hydraulic, pneumatic, steam, fresh water, salt water, fuel, ventilation, communication, weapons, fire control, damage control. And every one was being modified during construction based on combat reports from the Pacific. In 1941 alone, the Cleveland-class light cruiser working plans underwent 127 major modifications. While the ships were already being built, changes ranged from redesigned ammunition hoists to entirely new sterns. New York Shipbuilding, the lead yard for Cleveland-class cruisers, complained to the Navy, "We have been urged repeatedly by the Secretary to expedite production in every possible way, and one of the factors that will affect ultimate expedited delivery of all ships is the number of changes imposed during the building period." Rear Admiral Samuel Robinson of the Bureau of Ships replied by quoting Hamlet, "We are continually resisting the ordering of any changes. As you must recognize, however, eliminating all changes is a consummation devoutly to be wished, which unfortunately is not quite yet within our grasp." Translation: Combat experience was producing lessons faster than ships could be completed. The Navy needed those improvements incorporated, even if it complicated production. So how did American yards build so many ships so fast? The answer: batch production combined with specialized expertise. Newport News Shipbuilding served as the lead yard for Essex-class carriers, because it had successfully developed the preceding Yorktown-class design in the 1930s. The yard's naval architects and marine engineers knew carriers intimately. When the Essex program began, Newport News developed the detailed construction plans, the working blueprints that translate design into reality. These plans were then distributed to the follow-on yards: Bethlehem Fore River Brooklyn Navy Yard and Philadelphia Navy Yard. Each yard built multiple ships using these plans, but each also incorporated improvements as they learned. The same system applied to other ship types: New York Ship Lead Yard for Cleveland-class light cruisers, Bath Iron Works Federal Ship, specialized in Fletcher-class destroyers, Mare Island, Portsmouth, and other yards, specialized in submarines. This wants assembly line production. It was coordinated batch production by expert craftsmen using shared plans and continual improvement. And it worked because of the workforce. At Newport News, more than 80% of foremen had worked at the yard their entire lives. Average tenure over 30 years. These weren't temporary war workers. These were masters of their trades. The yard ran extensive apprenticeship programs, 4-year training programs that were accelerated but not abandoned during the war. Every year, Newport News recruited 1,000 high school graduates from small towns and rural areas in Southern Virginia and North Carolina. The apprentices received 8 hours per week of classroom instruction in mathematics, applied mechanics, physics, chemistry, English, and industrial economics. The rest of the week, hands-on training under experienced journeymen. The vocational training, which occupies the remainder of his work week, is under the direction of a whole-time instructor and covers the full scope of the craft training, qualifying him at completion as a first-class journeyman mechanic in his trade, explained Homer Ferguson, the yard's president. Beyond apprentices, the yard trained 8,000 upgraders, workers brought up to speed on specific tasks in about 3 months. These weren't fully trained craftsmen, but they could perform definite operations very well. You can teach men to do definite things, Ferguson emphasized. The workforce peaked at 30,000 in 1943. This included 1,200 women, 8,000 black men, thousands of skilled tradesmen, thousands of semi-skilled workers. Wage discrimination was pervasive. Black workers earned less for identical work. Women faced similar discrimination. But the ships got built, and they got built fast. Newport News alone completed 9 Essex-class carriers during the war. Yorktown commissioned, November 1943. Franklin commissioned, January 1944. Shangri-La commissioned, September 1944. Lake Champlain commissioned, June 1945. The follow-on yards built 15 more. 24 Essex-class carriers total, plus 9 Independence-class light carriers converted from cruiser hulls, plus dozens of escort carriers. By mid-1943, the pattern was established and the tempo was increasing. And in Tokyo, Japanese naval intelligence was beginning to notice. Pacific Theater, mid-1943. Japanese Naval Intelligence Headquarters. Lieutenant Commander Nakajima sits at his desk surrounded by reports. His job track: American naval construction. Estimate completion dates. Project American fleet strength. The numbers don't make sense. According to their pre-war assessments, America would need years to recover from Pearl Harbor. Building a fleet carrier took 48 months minimum. Building a battleship took even longer. Yet the reports coming in tell a different story. May 1943, USS Essex arrives at Pearl Harbor. The first of the new class. Expected if unfortunate. July 1943, USS Yorktown arrives. All right, 2 ships. Americans have resources. August 1943, USS Lexington arrives. Also August, USS Intrepid commissioned. Will arrive soon. November 1943, USS Hornet commissioned. USS Bunker Hill already operating. Nakajima checks his sources, rechecks the intelligence. 3 carriers arriving within months of each other. More commissioning. The Americans aren't just replacing losses, they're expanding. He requests verification through neutral observers, through spy networks, through any available source. The reports come back. Confirmed. All confirmed. Plus light carriers. The Independence class. Converted from cruiser hulls, smaller but fast enough to operate with fleet carriers. 9 of them being commissioned in rapid succession. Plus escort carriers. Dozens of them. Small, slow, built on merchant ship hulls but useful for convoy protection and amphibious operations. Nakajima prepares his report for the Admirals. He tries to maintain professional objectivity, but the implications are clear. American carrier strength in the Pacific, December 1941. 3 fleet carriers, December 1943. Fleet carriers, December 1943. 11 fleet carriers plus light carriers plus escort carriers. The curve is exponential, and Nakajima's projections suggest it will continue. His sources indicate at least a dozen more Essex-class carriers under construction at various American yards. Completion dates scattered through 1944 and into 1945. The admirals read his report. Some dismiss it. Surely the numbers are exaggerated. Intelligence is often unreliable. Perhaps the Americans are commissioning ships that aren't fully ready, inflating their numbers. But other officers note the evidence from combat. The new American carriers are arriving in the Pacific, and they're immediately effective. Well-trained crews, modern equipment, superior aircraft. These aren't half-finished ships rushed into service. These are fully capable combatants. One captain does the mathematics. If they maintain this pace, they'll have 20 carriers by the end of 1944. Silence in the room. Japan's entire carrier force, the pride of the Imperial Navy, currently numbers 9 fleet carriers. And that's after frantic construction and conversion efforts since Midway. They can't maintain this pace, someone says. The resources required, the manpower, it's impossible. But the reports keep coming in, and the American carriers keep arriving. To understand how American yards achieved what Japanese planners thought impossible, you have to look behind the statistics, into the shipyards themselves, into the organization that made it possible. Start with government investment. The federal government poured $229.8 million into private shipyards between 1940 and 1942. This wanted loans. This was direct financing of facility improvements, equipment purchases and expansion projects. Newport News. Shipbuilding. $21.6 million. New slipway for carriers. Machine shop expansion. Fabrication plant for armor and complex assemblies. Additional pier for outfitting. New cranes including hammerhead crane for heavy lifts. Bethlehem. Fore River. $21.1 million. 3 additional building ways. Entire machine shop devoted solely to turret fabrication. New welding facilities with X-ray inspection equipment. Boring mills, lathes, and precision tools. Hammerhead crane with 120-ton capacity. New York shipbuilding. $20.3 million. Middle yard annex with 5 additional slipways. Expanded machine capacity. New assembly facilities. Brooklyn Navy Yard. $71 million. 2 superdocks each. 1092 feet long. These massive facilities could build the largest ships. Heavy cranes, including one rated for 175 tons. Expanded workforce facilities. Philadelphia Navy Yard received 2 similar superdocks, and the pattern repeated across the country. Mare Island in California, Puget Sound in Washington. Bath Iron Works in Maine. Everywhere expansion. But facilities were only part of the equation. The true innovation was in organization and coordination. In 1940, Congress suspended competitive bidding for naval contracts. Instead, the Bureau of Ships assigned contracts to yards based on expertise and experience. No more lowest bidder. Instead, best qualified. This enabled specialization. Newport News lead yard for Essex-class carriers because they designed the preceding Yorktown class. Their naval architects knew carrier design intimately. They developed the Essex-class working plans and distributed them to follow-on yards. New York Ship lead yard for Cleveland-class light cruisers because they designed Brooklyn-class cruisers in the 1930s. Same principle. Build on existing expertise. Bath Iron Works and Federal Shipbuilding specialized in Fletcher-class destroyers. Both yards had built destroyers before the war. Both worked with Gibbs-Cox naval architects who developed Fletcher-class plans. This specialization meant each yard could focus on what it did best and continuously improve. But specialization only works if you can coordinate production across multiple facilities. The Bureau of Ships created that coordination through its planning statistics branch. Every bureau in the Navy Department used uniform tabulation systems to record and track progress on contracts. Data flowed to planning statistics, which compiled the monthly status report, a document tracking 800 controlling items across all naval production. Controlling items were the critical components that determined overall production schedules. Hulls, propulsion machinery. Armor plate, major weapons systems. Electronics. The monthly status report created timelines 12 to 18 months out for each controlling item. This allowed the Navy to synchronize production sequences across bureau lines and across multiple contractors. Example: hull construction statistics from Bureau of Ships could be cross-referenced with valve production data from subcontractors. This enabled scheduling valve delivery precisely when the hull reached the stage that needed them. No massive stockpiles, no waiting for parts. Just-in-time delivery before that concept had a name. The system also alerted the War Production Board about future Navy needs. If Essex-class hulls would reach a certain stage in 3 months, the Navy could tell WPB, "Well, need this much armor plate, this many valves, this much electrical cable at that time." It was coordination on a scale never before attempted. And it worked because of the network of subcontractors. Shipyards built ships, but they didn't build everything that went into ships. Propulsion systems came from specialized manufacturers: Curtiss turbines, reduction gears, boilers. Armor plate came from steel mills: Bethlehem, Steel Carnegie, Illinois Steel. Only a few mills could produce the specialized armor plate for warships. Weapons systems came from Navy arsenals and contractors: gun turrets, fire control equipment, torpedo tubes, anti-aircraft mounts. Electronics came from dozens of contractors. Radar systems, radio equipment, sonar systems. Everything else came from thousands of smaller suppliers. Valve, pumps, electrical fittings, ventilation systems, anchors, and chains, paint, insulation furniture, galley equipment. A single Essex-class carrier required components from hundreds of suppliers coordinated across dozens of states, all timed to arrive at the shipyard when needed. It was the opposite of vertical integration. It was disintegrated production on a massive scale. And it mobilized American industrial capacity far more effectively than any single giant factory could have. Consider the Philadelphia Navy Yard superdock as an example of this coordination in action. Originally designed to build the Montana-class battleship, one of the 192-foot superdocks was repurposed when Montana construction was canceled before keel laying in 1942. The dock then handled a tightly sequenced series of projects: February-July 1942. 6 destroyer escorts built simultaneously launched together August 1942. Landing craft Batch 1, November 1942. Landing Craft Batch 2. February-May 1943. 6 more destroyer escorts, August 1944. 2 Baltimore-class heavy cruisers floated out September 1944. Essex-class carrier Valley Forge, keel laid 1 building dock. Multiple ship types. Continuous production. Maximum utilization of the facility. The other Philadelphia superdock followed a similar pattern, including Essex-class carrier Antietam and 2 Oregon-class heavy cruisers. This flexibility, this ability to shift production, adapt to changing needs, and maximize efficiency, was something Japan couldn't match. Japanese yards built ships one at a time, start to finish, with each being a masterwork of craftsmanship. American yards built ships in coordinated batches with continuous improvement and shared learning. Both approaches had merit, but only one could scale to meet the demands of global war. Kure Naval Arsenal, Japan. Autumn 1943. Master shipwright Tanaka surveys the construction slip where Yamato was born. That mighty battleship, pride of the fleet, now operates somewhere in the Pacific. Her sister Musashi recently completed trials and joined the fleet. Both represent the pinnacle of Japanese naval construction. 4 years each from keel laying to commissioning. Every plate perfect, every weld inspected, every system tested and retested. Quality without compromise. But now, looking at the slips, Tanaka sees problems. Where experienced craftsmen once worked, he sees conscripted laborers. Where precision teams once coordinated complex installations, he sees schoolboys and Korean forced laborers, struggling with tasks they barely understand. The skilled workers, the men who knew ships, had spent decades mastering their trades, have been drafted. Some went to the army, others to the navy as sailors rather than builders. The military needs fighting men more than shipbuilders, or so the reasoning goes. The replacements try. They work hard, but welding a ship's hull isn't something you learn in a week. Reading blueprints takes training. Understanding how systems interconnect requires experience. Tanaka watches a young apprentice attempting to install a valve assembly. The boy has the manual. He has the tools, but has never done this before, and has working alone, no experienced fitter to guide him. The quality is declining. Tanaka can see it. Everyone can see it. And there's another problem: steel. Japan's steel production peaked in 1943 at 7.8 million tons, but maintaining even that level requires raw materials, coking coal and iron ore, most of which must be imported. Imported by ship, across sea lanes that American submarines now patrol with increasing effectiveness. The vicious circle tightens. Need steel to build ships. Need ships to import raw materials. Need raw materials to make steel. Need fuel to run ships. Need ships to transport fuel. And American submarines sink the ships. In 1942, Japan lost just 4 tankers. Unfortunate but manageable. In 1943, the number rose to 23. And the trend is accelerating. Tanaka, this could have to steady have for is his oddis. Steady have to steady have for is his oddis. This could have for is his oddis. This could have for is his oddis. In 1944, the directive comes down: large warship construction slows or stops. Small warship production increases. Resources shift to building tankers. Desperate attempts to keep oil flowing from Borneo and Sumatra to Japan's refineries. But only 1/6 of steel production now goes to warship construction. At Kure, work continues on carrier conversions. The passenger liner Kashiwara Maru becomes Taiyo, then later Kaiyo. Escort carriers cobbled together from merchant hulls. The submarine tender Taijai, damaged in the Doolittle raid, is converted to light carrier Ryuho. These conversions are necessary. After the loss of 4 fleet carriers in a single day, Japan needs carriers desperately, but conversions or rent purpose-built warships. The array compromises. Passenger liner hulls never designed for combat, retrofitted with flight decks and hangar spaces. Adequate perhaps, but not optimal. Tanaka remembers when Kure built Yamato. The pride, the precision, the 4 years of focused effort that produced the ultimate battleship. Now, rushed conversions, declining quality, shortages of everything. He walks past the slip where Shinano is taking shape, a Yamato-class hull being converted into a carrier. At 72,000 tons, shall be the largest carrier ever built. But the conversion is complicated, the work proceeding slowly. Yokosuka Navy Yard is handling similar conversions. Sasebo is building escorts. Maizuru is producing whatever resources allow. The 4 great Navy yards, once the pride of the Imperial Navy, are working at capacity. But capacity is constrained by steel shortages, labor shortages, and increasingly by American air raids. In late 1944, B-29 bombers will begin striking Japanese industry. Kure will be heavily damaged. The Hiro Naval Aircraft Factory nearby will be devastated. Many of the surviving ships of the Imperial Navy will be sunk or disabled at anchor. But that's still in the future. For now, in autumn 1943, Tanaka simply sees the decline, sees the strain, sees the gap between what Japan needs and what Japan can produce. Across the Pacific, American yards are accelerating. In Japan, the yards are struggling. The outcome seems increasingly inevitable. Pearl Harbor, July through December 1943. If you stood at the harbor entrance during this period and watched, you'd witness something unprecedented in naval history. July 1943, USS Yorktown arrives. The ship in a hurry that beat Essex to Pearl Harbor. Captain Jocko Clark brings her in, crew eager to prove themselves. Also July, USS Lexington arrives. Named for the carrier lost at Coral Sea. Her crew carries the legacy of the original Lady Lex. August, USS Princeton, first of the Independence-class light carriers. Converted from a Cleveland-class light cruiser hull. Smaller than Essex-class but fast, capable of operating with the fleet carriers. Carries fewer aircraft but adds another flight deck to the growing armada. Also August, USS Intrepid arrives. Will later be called Evil Lied for her tendency to attract Japanese attention and survive. September, USS Belleau Wood, another Independence class. October, USS Cowpens. November, USS Bunker Hill. USS Hornet commissioned, preparing for transit. Also November, USS Wasp, named for the carrier lost in 1942. USS Monterey joins the light carrier force. December, USS Hancock commissioned. 6 months. 12 carriers join the Pacific Fleet. Not counting the escort carriers arriving in parallel. Not counting the battleships, cruisers, destroyers, submarines. Just the fleet and light carriers, 12 in 6 months. The Japanese calculations, the pre-war assessments that building a carrier required 48 months, are being demolished by reality. American yards aren't building one carrier every 4 years. They're commissioning one every 2 weeks. Let that sink in. Every 14 days on average, another American carrier enters service, and the pace is increasing. The Essex-class production schedule tells the story. 1943 Essex, December 31, 1942. Yorktown, April 15, 1943. Intrepid, August 16, 1943. Hornet, November 29, 1943. Lexington, February 17, 1943. Bunker Hill, May 24, 1943. Wasp, November 24, 1943. 1944. Bennington, August 6, 1944. Bonhomme, Richard, November 26, 1944. Ticonderoga, May 8, 1944. Randolph, October 9, 1944. Franklin, January 31, 1944. Shangri-La, September 15, 1944, 1945. Antietam, January 28, 1945. Boxer, April 16, 1945. Princeton, November 18, 1945. Tarawa, December 8, 1945. Blacksir, Bat's Wife. Carriers, Wiles, Tara. Batstor, 1944. Texer, Lear, plus more than 50 escort carriers. The title of this story isn't hyperbole. At peak production, a new American carrier was indeed joining the fleet, approximately every week. In Tokyo, Japanese naval intelligence stares at the numbers and struggles to comprehend. Commander Nakajima updates his projections. Each month brings new data, new arrivals, new evidence of American industrial capacity, operating at levels that seem impossible. His reports to the Admirals grow increasingly urgent. American carrier strength in Pacific. As of December 1943, 11 Essex-class fleet carriers, 9 Independence-class, 5 fleet carriers, against 20 American fleet and light carriers, with more arriving monthly. Where is Tai-Ho? Someone asks. When does she commission? March 1944. An aide responds. She will be our most advanced carrier. Armored flight deck. Modern systems. 1 carrier. Against the American flood. The mathematics are brutal. But numbers don't tell the complete story. Quality matters too. Training matters. Aircraft matter. Pilot experience matters. And on all these measures the gap is widening. American carrier crews train stateside for months before deploying. They practice launches and recoveries until procedures become automatic. They drill damage control until crews can respond to casualties in darkness, in smoke, in chaos. Japanese carrier crews, the veteran air crew who struck Pearl Harbor, who fought at Coral Sea and Midway, have been decimated. Replacements receive abbreviated training. Fuel shortages limit flight hours. American submarines make training operations dangerous even in home waters. American aircraft improve constantly. The F-6F Hellcat enters service in 1943. Faster than the Zero, more heavily armed, more rugged. The SB-2C Helldiver dive bomber carries heavier bomb loads than earlier types. The TBF Avenger torpedo bomber is effective and survivable. Japanese aircraft designs, once superior, are aging. New designs are in development, but production struggles with resource constraints. At the Battle of the Philippine Sea in June 1944, the disparity will become devastatingly clear. American pilots will call it the Great Marianas Turkey Shoot. In a single day, Japanese naval aviation will effectively cease to exist. But that's still months away. For now, in late 1943 and early 1944, the disparity will become devastatingly clear. American pilots will call it the Great Marianas Turkey Shoot. In a single day, Japanese naval aviation will effectively cease to exist. But that's still months away. For now, in late 1943 and early 1944, the American buildup continues. And it's not just carriers. John Woodward, general manager, oversees the yard's transformation from peacetime operation to wartime powerhouse. He coordinates with the Navy Department, manages the 30,000-person workforce, ensures materials arrive when needed. Homer Ferguson, the yard's president, becomes one of the Navy's most trusted industry partners. His expertise in carrier construction is so valued that Hell later be commissioned as a rear admiral and put in charge of production for the entire Navy. James McCall runs the turret shop. He came to Newport News from Cramp Sons in Philadelphia in 1935, when the yard needed a turret specialist for Brooklyn-class cruisers. His division moved into a new building in 1941 to produce turrets for Cleveland-class cruisers, now has overseeing turret production for carriers and battleships simultaneously. In the Apprentice Training Center, young men from Virginia and North Carolina farms are learning trades that will define their lives. Many have never seen the ocean before arriving at Newport News. Now they're installing equipment on ships that will sail across the Pacific. The upgraders. The 8,000 workers trained in specific tasks master their roles. One woman becomes expert at a particular welding operation. She can do it in darkness. She can do it in awkward positions. She does it thousands of times, and every weld holds. An African-American riveting gang works on an Essex-class carrier's hull. The noise is deafening. Pneumatic hammers driving hot rivets home. The heat is oppressive. Summer in Virginia working in enclosed spaces. The work is exhausting. They earn less than white workers doing identical jobs. But they're building the ships that will win the war, and they know it. At Bethlehem, Fore River, Massachusetts, the yard runs 3 shifts 24 hours a day. Workers stream in and out of the gates at shift change. Welding arcs light up the night. The sounds of construction never stop. Hammering, grinding, cutting, lifting. 4 Essex-class carriers are built here, plus cruisers and destroyers. The yard expands from 7 building ways to 10. The new machine shop, devoted entirely to turrets, operates constantly. A young engineer solves a problem with turret assembly that's been slowing production. His solution saves 2 days per turret. 2 days times dozens of turrets means ships commissioning weeks earlier. He receives a commendation. He'll remember it for the rest of his life. At Brooklyn Navy Yard, New York, 71,000 workers. The largest employer in New York City. The yard operates 2 massive superdocks, each 1,002 feet long. In these docks, Iowa-class battleships take shape alongside Essex-class carriers. A crane operator named Mike positions the 175-ton crane over Iowa's hull. Below, workers guide a 16-inch gun turret into position. The turret weighs hundreds of tons. The clearances are measured in inches. Mike has done this dozens of times, but he never gets comfortable. One mistake, one slip could kill people and destroy months of work. The turret settles into place perfectly. Workers below signal thumbs up. Mike allows himself a moment of relief, then moves to the next lift. Women work throughout the yard, as crane operators, welders, electricians, painters. They face skepticism from male workers, harassment from supervisors, discrimination in pay. But they do the work. The ships get built. Brooklyn Navy Yard builds 4 Essex-class carriers and 2 Iowa-class battleships during the war, plus repairs 5,000 ships damaged in combat. The yard never stops. At Philadelphia Navy Yard, the superdocks host a parade of ships. Destroyer escorts launch in batches. Landing craft are built in series. Heavy cruisers take shape. Essex-class carriers receive their keels. A welder works inside a narrow space in a carrier's hull. It's hot, cramped, dark. She can barely move. But the weld must be perfect. This is a strength member, part of the ship's structural integrity. She takes her time, does it right. Later, that carrier will survive a kamikaze hit. The structure will hold, because the weld's held. At Bath Iron Works, Maine. The yard specializes in destroyers. Fletcher-class destroyers, the Navy's workhorses. Bath builds them faster than any other yard, averaging 262 days from keel laying to commissioning. The workers are proud of this record. They compete with Federal Shipbuilding in New Jersey, which averages 194 days. The rivalry is friendly but intense. Each yard wants bragging rights. A Bath worker explains the secret: "We know destroyers. We've been building destroyers since before the war. Every time we build one, we learn something. Every time we launch one, we start the next one with that knowledge." Bath Iron Works builds 175 Fletcher-class destroyers during the war. Each one serves in the Pacific. Each one represents 262 days of focused effort by hundreds of people. The common thread. These aren't temporary war workers doing unfamiliar tasks. These are craftsmen building on decades of experience. Yes, they're joined by new workers. Women entering the workforce, minorities given opportunities, young people learning trades. But the core workforce brings expertise. Newport News foremen average 30 years at the yard. 30 years. These men know ships the way a carpenter knows wood. And they're supported by the vast network of subcontractors in Philadelphia. A valve manufacturer receives specifications for a new valve design needed for Essex-class carriers. They prototype it, test it, refine it, then manufacture thousands. Every valve must work perfectly. Ships' systems depend on them. In Connecticut, engineers at Pratt Whitney develop new aircraft engines. In California, other engineers work on radar systems. In dozens of states, hundreds of companies produce the components that shipyards assemble into warships. It's not one miracle. It's thousands of small successes coordinated into a larger triumph. Captain Jocko Clark, driving his crew and the shipyard workers to commission Yorktown on schedule, represents one visible example. But the real heroes are the thousands of invisible ones. The welder in the narrow space, the crane operator with steady hands, the apprentice learning his trade, the engineer solving problems, the foreman coordinating complex work, the manager ensuring materials arrive on time. Together they achieve what Japanese planners thought impossible. They build a fleet every year. While American shipyards churned out vessels, the Pacific War continued. Ships were being sunk even as new ones were being built. The question became, could America build ships faster than Japan could sink them? The answer arrived in 1944. American losses: USS Princeton, October 24, 1944. Battle of Leyte Gulf. Japanese dive bomber lands a hit on her flight deck. The bomb penetrates to the hangar deck, where armed aircraft are being prepared for launch. Secondary explosions tear the ship apart. Abandoned and scuttled. USS Gambier Bay, October 25, 1944. Battle off Samar. Escort carrier caught by Japanese surface forces. Hit by cruiser and battleship fire. Sinks with heavy loss of life. Multiple other carriers damaged but return to service. Essex-class carriers prove remarkably survivable. Their design incorporates lessons from earlier carriers. USS Franklin, March 19, 1945, hit by Japanese dive bomber off Japan. Devastating fires. Hundreds killed. Ship nearly lost. But damage control saves her. She limps back to Pearl Harbor under her own power, eventually makes it to Brooklyn Navy Yard for repairs. Franklin's survival demonstrates the quality of American shipbuilding. Damage that would have sunk earlier carriers, that did sink carriers at Coral Sea and Midway, is survivable now. American replacements. For every carrier lost, multiple replacements arrive. Princeton sunk October 1944. By that time, 7 new Essex-class carriers have commissioned in 1944 alone, plus the new Princeton is under construction. The mathematics are simple and brutal. Japan cannot sink American carriers faster than American yards can build them. Japanese losses. May-June 1944. The Imperial Navis carrier force effectively ceases to exist. Tai-Ho, June 19, 1944. Battle of the Philippine Sea. Newest, most advanced Japanese carrier. Armored flight deck. Modern design. Hit by one torpedo from USS Albacore. Damage control errors lead to fuel vapors spreading through the ship. Hours later, massive explosion tears her apart. Sinks. Shokaku, June 19, 1944. Same battle. Veteran of Pearl Harbor, Coral Sea, Santa Cruz. Hit by 4 torpedoes from USS Kavala. Sinks. Hio, June 20, 1944. Hit by aerial torpedoes. Sinks. At the Battle of the Philippine Sea, Japan launches wave after wave of aircraft against American carrier task forces. American fighters and anti-aircraft fire cut them down. Of approximately 400 Japanese aircraft that attack, 340 are shot down. American pilots call it the Great Marianas Turkey Shoot. Japanese naval aviation never recovers. Not enough trained pilots. Not enough aircraft. Not enough carriers to operate from. October 1944. Battle of Leyte Gulf, Suikaku. Veteran of Pearl Harbor. Last surviving carrier from that attack. Hit by multiple bombs and torpedoes. Sinks October 25. Chitos Light Carrier. Sunk October 25. Chitos Light Carrier. Sunk October 25. Tsuiho Light Carrier. Sunk October 25. Tsuiho Light Carrier. Sunk October 25. Tsuiho. Shinano. They. Converted Yamato-class battleship. Largest carrier ever built. Commissioned just 10 days earlier at Yokosuka Navy Yard. On maiden voyage to Kure for final fitting out. Hit by 4 torpedoes from USS Archerfish. Poor damage control, poor watertight integrity, incomplete training. Sinks. The largest carrier ever built sunk by a submarine before she could enter combat. Japanese replacements. None. Japan has no more fleet carriers. A few escort carriers remain converted from merchant ships, but very inadequate for fleet operations. More critically, Japan has no pilots. The experienced aircrew are dead. Training programs can't replace them fast enough. Fuel shortages limit flight training. The pilots who do graduate are sent into combat with minimal hours in their aircraft. American pilots, by contrast, receive hundreds of hours of training before joining fleet squadrons. They practice gunnery navigation carrier landings. When they arrive in combat zones, they're ready. The comparison in oil tells the larger story. Japanese oil situation 1942. 40% of East Indies crude oil production reaches Japan. Tankers lost 132. After March 1945, 0% tankers lost in first 8 months of 1945. 103. Japan launches a desperate tanker construction program. Converts merchant ships to carry oil. But each tanker requires steel. Steel production requires coking coal and iron ore, which must be imported. Imports require ships. The vicious cycle tightens. Steel production tells the story. 1943 peak 7.8 million tons, 1945, 1.5 million tons. With 85% of steel production capacity idle. Japan cannot build ships, cannot build aircraft, cannot build weapons, cannot sustain war production. American submarines are strangling Japan's war economy. And American shipyards are building the submarines. Submarine warfare. American submarines sink 100 Japanese merchant ships during the war. More aggregate tonnage than Japan possessed on December 7, 1941. They also sink 2,001 Japanese warships, including carriers, battleships, cruisers, and destroyers. 52 American submarines are lost. Remain on patrol in submarine service. Euphemism. About 16,000 submariners make war patrols during the war. They represent just 2% of naval personnel but account for 50% of all Japanese ships sunk and 60% of tonnage destroyed. Every one of those submarines was built in an American shipyard: Portsmouth Navy Yard, New Hampshire Mare Island Navy Yard, California Electric Boat Company, Connecticut Manitowoc Shipbuilding, Wisconsin. From 1940 to 1945, American yards deliver more than 200 fleet submarines, Gato Balayo and Tench classes. Japan starts the war with superior submarines and superior torpedo technology. But Japanese submarines are used primarily for fleet operations, not commerce warfare. They sink relatively few American merchant ships. American submarines, by contrast, systematically destroy Japan's merchant marine. The island nation dependent on imports for survival cannot replace losses. Once again, American shipyards build faster than the enemy can destroy. By mid-1945, the numbers tell an unambiguous story. American naval construction, December 1941, August 1945. Essex-class fleet carriers 17 commissioned before war's end. Independence-class light carriers 9, escort carriers 50. Iowa-class battleships 4. Iowa commissioned February 1943, New Jersey commissioned May 1943, Missouri commissioned June 1943, Missouri commissioned June 1943, Missouri commissioned June 1943, Missouri commissioned June. Total tonnage delivered by American yards 1941 to 1945, approximately 10 million tons of naval vessels. Japanese naval construction, December 1941, August 1945. Fleet carriers, new construction, 0. Carrier conversions, several including Shinano, sunk before entering combat. Junyo and Hyo, both sunk. Various light carriers from cruiser and tender hulls, nearly all sunk. Battleships completed. 1 cruisers. A handful, destroyers. Modest numbers, declining quality. Submarines, modest numbers, declining quality. Submarines, modest numbers. Escorts, insufficient numbers, too late. Total tonnage delivered by Japanese yards, 1941 to 1945, approximately 500,000 tons. The comparison is stark. American yards built 20 times as much tonnage as Japanese yards. And American vessels were on average more capable, more survivable, better equipped. But raw numbers don't capture the complete picture. Quality considerations. American ships incorporated combat lessons throughout construction. As reports came back from the Pacific, changes were made to ships still being built. Additional anti-aircraft guns, improved radar systems, better damage control equipment. Training differences. American crews trained extensively before deploying. Carrier crews practiced launches and recoveries for months. Damage control drills became second nature. Gunnery training produced accurate fire. Japanese crews received abbreviated training. Fuel shortages limited practice time. Experienced sailors were killed and couldn't be adequately replaced. Aircraft differences. By 1944, American carrier aircraft were superior in nearly every respect. F-6F, Hellcat fighter, faster, more rugged, heavier armed than 0 SB-2C. Helldiver, effective dive bomber. TBF, Avenger, reliable torpedo bomber. Japanese aircraft designs, once cutting edge, were aging. New designs existed, but production struggled. Logistics differences. American carriers operated with massive fleet trains. Oilers, ammunition ships, stores ships, repair ships. Task forces could operate for weeks without returning to port. Japanese carriers lacked adequate logistics support. Operations were constrained by fuel availability, ammunition supplies, parts for repairs. The decisive difference, but the truly decisive difference, was sustainability. America could lose ships and replace them, could lose pilots and train new ones, could lose aircraft and build more. The industrial base supported continuous operations at high tempo. Japan couldn't replace losses. Every ship sunk was irreplaceable. Every pilot killed was irreplaceable. The industrial base was collapsing under submarine warfare and strategic bombing. By early 1945, Japan's remaining carriers, few in number, sat in port without fuel, without aircraft, without pilots. American carriers, by contrast, operated off Japan's coast with impunity. The Fast Carrier Task Force, built around Essex-class carriers, could put more than 1,000 aircraft into the sky. The war was decided not just by battles but by shipyards. American shipyards won. September 2nd, Tyne, 1945. We return to where we began. The unnamed Japanese admiral stands on Nagato's deck, surrounded by the evidence of his nation's defeat. Missouri dominates the view. Commissioned June 1944 at Brooklyn Navy Yard. 15 months from commissioning to hosting the surrender ceremony. Keel to Tokyo Bay in less than 3 years. Surrounding Missouri. The fleet. Fleet carrier Bataan, built by New York Shipbuilding, arrives from the Philippines. Heavy cruiser Quincy, built at Bethlehem Fore River, lies at anchor nearby. Chez, a Baltimore-class cruiser, one of 14 built during the war. She was commissioned in June 1943, 25 months ago. Light cruiser Oakland, built at Bethlehem's San Francisco Yard. Fletcher-class destroyer Caperton, from Bath Iron Works. Destroyer escort Kendall C. Campbell from Federal Shipbuilding. And somewhere in the bay, USS Archerfish, the Portsmouth Navy Yard submarine that sank Shinano. The submarine crew surely savors the irony. There, anchored near the spot where Japan's largest carrier lies at the bottom, sunk before she could fight. The Admiral's mind drifts to his own ship. Nagato, launched in 1919 at Kure Navy Yard. She was modern once, powerful once. She served as Admiral Yamamoto's flagship at Pearl Harbor, the beginning of Japan's war. Now Chez, obsolete, outdated, a relic, one of the few surviving capital ships of the Imperial Navy. He thinks of the others. Yamato sunk April 1945, Operation 10 Go. The ultimate battleship sent on a one-way mission without enough fuel to return. Killed by aircraft from American carriers. Musashi sunk October 1944. Battle of Leyte Gulf. Hit by an estimated 19 torpedoes and 17 bombs from American carrier aircraft. The carriers all gone. Sunk in battles from Midway to Leyte Gulf. The cruisers most sunk. The destroyers hundreds lost. Japan entered the war with qualitative superiority. The Zero was superior to any American fighter. Japanese torpedoes were more advanced. Japanese night fighting tactics were better practiced. Japanese naval aviation was more experienced. Those advantages lasted perhaps a year. Then American production buried them. The Admiral thinks back to 1941. The confident assessments. The laughter in conference rooms. Americans can't build ships quickly. Their yards are inefficient. It will take them years to recover. How many times did he hear such statements? How many times did he nod in agreement? Yamamoto had warned them. Yamamoto, who understood American industrial capacity. But even Yamamoto missed the critical element. He spoke of Detroit factories and Texas oil. He never quite grasped what American shipyards could achieve. The Admiral looks again at Missouri, at the carriers on the horizon, at the cruisers, destroyers, submarines. In less than 4 years, America built this fleet. From a standing start after Pearl Harbor, they created the most powerful naval force ever assembled. Japan, with its head start, with its experienced workforce, with its proud naval arsenals, couldn't match it, couldn't come close. The mathematics were brutal, the outcome inevitable. Representatives of the Japanese government board, Missouri. Foreign Minister Mamoru Shigemitsu limps up the gangway. His leg was lost in an assassination attempt years ago. General Yoshijiro Umezu follows. They will sign the surrender documents. The war will officially end. But the war was really decided in the shipyards, decided by welders in Newport News, by crane operators in Brooklyn, by riveters at Fore River, by all the thousands of workers who built the ships that carried American power across the Pacific. The Admiral watches the ceremony from a distance, watches Japan's surrender made official. 3 years ago in planning rooms in Tokyo, they had laughed at American shipyards. Today, surrounded by American steel, the laughter is a distant, bitter memory. Why did Japanese planners miscalculate so badly? The answer lies in understanding what they couldn't see. Cultural blindness. Japanese naval tradition emphasized craftsmanship and perfection. Ships were masterworks. Each one represented years of focused effort by skilled artisans working to exacting standards. Yamato took 4 years from keel laying to commissioning. Every weld was inspected. Every fitting was perfect. Every system was tested and retested. The result was arguably the finest battleship ever built. This approach produced quality, but it couldn't produce quantity. Japanese planners assumed American shipbuilding would follow similar patterns. Quality takes time. Complex weapons systems can't be rushed. Therefore, American yards would need years to build carriers. They couldn't conceive of an alternative approach. Yamamoto's partial vision. Admiral Yamamoto saw American industrial capacity more clearly than his colleagues. His time in America, Harvard, Washington, Detroit, Texas, showed him American scale. He saw Ford's River Rouge plant and understood mass production. One Model T every 45 seconds. The efficiency, the standardization, the volume. He saw Texas oil fields and understood resource abundance. America had petroleum that Japan lacked. He put these observations together and warned Japan cannot compete with American industrial capacity in a prolonged war. But Yamamoto made a crucial assumption. Naval construction couldn't follow automotive production models. Ships were too complex, too large, too specialized. He was right, but only partially. Warships couldn't be built on assembly lines. But they could be built using batch production methods that borrowed principles from mass manufacturing, while respecting the complexity of naval construction. Yamamoto saw Detroit and missed the connection to shipyards. He understood American manufacturing capacity, but underestimated how it could be applied to naval construction. Even the one Japanese admiral who truly grasped American power missed the most important element: the American innovation. What American shipyards developed during World War II was neither mass production nor traditional artisanal construction. It was something in between, something uniquely suited to warship building. Call it coordinated batch production. The elements: 1. Standardized designs with continuous improvement. Essex-class carriers used a common design, but the design evolved based on combat experience. Sages were incorporated into ships still under construction. Result: standardization where possible, improvement where necessary. 2. Specialized yards building multiple units. Newport News built 9 Essex-class carriers. Each ship benefited from lessons learned on previous ships. Workers became expert at specific tasks through repetition. Construction time decreased with each successive hull. Result: learning curve effects without assembly line rigidity. Say, lead yard system. 1 yard developed detailed construction plans. Plans distributed to follow-on yards. All yards built to same specifications but shared improvements. Result: coordination without centralization. 4. Government-financed infrastructure. $229.8 million invested in private yards. New slipways, cranes, machine shops, welding facilities. Investments made before Pearl Harbor through 2 Ocean Navy Act. Result: capacity available when war began. 5. Long-term skilled workforce. Foremen with 30 years experience. 4-year apprenticeship programs. Core of expertise supplemented by trained semi-skilled workers. Result: quality maintained, despite rapid expansion. 6. Extensive subcontractor networks. turbines from specialized manufacturers, armor from steel mills, electronics from dozens of contractors, thousands of components from hundreds of suppliers. Result: mobilization of entire industrial economy. 7. Sophisticated coordination systems. Monthly status. Reports tracking 6,800 controlling items. Just-in-time delivery before the concept existed. Synchronizations across bureaus and contractors. Result: efficient use of resources, minimal bottlenecks. This system couldn't build ships as quickly as Ford built cars, but it could build sophisticated warships far faster than traditional naval arsenals. Japanese planners never imagined this approach, because it didn't fit their mental models. Ships were either mass-produced or handcrafted. The American system was neither, and both. A hybrid that leveraged industrial organization while respecting engineering complexity. Resource differences. But organization alone doesn't explain the disparity. Resources mattered. America in 1941. Steel production capacity 80 million tons annually. Oil production. Massive domestic reserves, plus access to Venezuelan oil. Electrical power. Abundant transportation. Intact. Rail network protected coasts. Labor large, population millions. Available for war work. Geography. Protected by oceans. Immune to strategic bombing. Japan in 1941. Steel production capacity 7 million tons annually, dependent on imported raw materials. Oil production negligible domestic, entirely dependent on imports from Southeast Asia. Machine tools limited production, many imported. Electrical power limited. Transportation vulnerable sea lanes, limited rail. Labor smaller population, many already conscripted. Geography island nation, vulnerable to submarine warfare and strategic bombing. The resource disparity meant Japan was fighting uphill from the beginning, but the organizational differences made it worse. Had Japanese yards been perfectly organized, they still couldn't match American production because they lacked resources. But their traditional approach, quality over quantity, perfection over speed, guaranteed they would fall further behind. The submarine factor. American submarines deserve special mention. They didn't just sink Japanese warships, they destroyed Japan's ability to sustain war production. By 1944, Japan couldn't get raw materials to its factories, couldn't get crude oil to its refineries, couldn't transport finished products to where they were needed. Steel production collapsed not because factories were bombed, but because iron ore and coking coal couldn't reach the mills. Shipyards couldn't build ships without steel, couldn't complete ships without components, couldn't crew ships without trained sailors. The American submarine campaign, enabled by American shipyards building 200 submarines, strangled Japanese industry. Meanwhile, American industry operated at full capacity, protected by geography and supplied by secure sea lanes. The compound effect. The final factor was compound growth. Every American carrier that entered service could protect more submarines operating against Japanese shipping, support amphibious operations that captured more islands, train more pilots for the growing carrier force, project more power against Japanese positions. Each carrier made the next carrier more effective. Japan faced the opposite spiral. Every carrier lost reduced ability to protect shipping. Reduced shipping meant less resources for shipbuilding. Less shipbuilding meant fewer ships to protect shipping. Fewer ships meant more losses. By late 1944, the spiral was irreversible. What could Japan have done differently? In hindsight, probably nothing that would have changed the outcome. Japan's resource constraints were fundamental. The decision to go to war with America was, as Yamamoto predicted, a gamble that could only succeed through negotiated settlement. But better shipbuilding strategy might have extended the war. Build more escorts earlier. Develop better anti-submarine warfare capabilities. Focus on submarines for commerce warfare against American shipping. Build more simpler ships rather than fewer perfect ships. But these choices would have required abandoning deeply held beliefs about naval warfare. The decisive fleet battle. The primacy of battleships and carriers. The importance of qualitative superiority. Japanese naval culture made those changes nearly impossible. American culture, more pragmatic and less traditional, adapted faster. When combat showed that Essex-class carriers needed more anti-aircraft guns, they got them, even if it meant modifications during construction. When destroyer escorts proved effective, hundreds were built. When submarines were sinking Japanese shipping, more submarines were built. Adaptation, flexibility, willingness to change. Combined with resources and organization, these cultural factors made American victory inevitable. Statistics can obscure the human reality. 10 million tons of naval vessels, 17 Essex-class carriers, 200 submarines. Behind every number, people. The workers. Shez, 23 years old, working third shift at Newport News. She learned to weld 6 months ago. A 3-month accelerated course, then on-the-job training. Now Shez inside a carrier's hull in a space so tight she can barely move, laying a weld that will help hold the ship together when Japanese bombs strike. It's hot. The arc is blindingly bright even through the welding mask. Her arms ache. Shez been welding for 6 hours straight with only brief breaks. But the weld must be perfect. Lives depend on it. She finishes, inspects her work, marks it complete. Moves to the next weld point. Tomorrow night. She'll do it again. And the night after. For months, until this carrier is complete. Then she'll start on the next one. She earns less than male welders doing identical work. She faces harassment from some male coworkers. Her boyfriend is in the Pacific serving on a destroyer. But Shez building the ships that will bring him home. Hez, 58 years old, a foreman at Brooklyn Navy Yard. Hez worked here for 34 years, since 1911. He remembers building ships for World War I. Remembers the lean years of the Depression when work was scarce. Now he oversees a crew of 40 workers installing equipment on an Iowa-class battleship. Half his crew are young men in their 20s. A quarter are women. Several are African American. Before the war, this crew would have been all white men, all with years of experience. Now, Hez teaching basics to people who've never worked in a shipyard. But they're learning. They're eager. They want to do this right. He shows a young woman how to read a blueprint. Shows her where this valve assembly must go, how it connects to the system, why it matters. She listens intently, asks smart questions, gets it done. He thinks, maybe the world is changing. Maybe that's not so bad. Hess, 19 years old. African American, part of a riveting gang at Bethlehem Fore River. The work is brutal. The hardest, dirtiest job in the yard. Pneumatic hammers shake your whole body. Hot rivets must be driven home precisely. The noise is deafening even with ear protection. His gang works on an Essex-class carrier's hull. 4 men, heater catcher, bucker up riveter. They move in synchronized rhythm perfected through repetition. Heat rivet. Toss it. Catch it in a bucket. Position it. Drive it home. Repeat. Hundreds of rivets per shift. Thousands per week. The hull takes shape 1 rivet at a time. He earns less than white riveters. He can't eat in the same cafeteria. Can't use the same facilities. After the war, he knows hell faced the same discrimination he faced before. But right now, right here, Hess building a warship. Hess part of something bigger than himself. And the rivets he drives will hold. When this carrier gets hit, And she will get hit. The hull will hold together. Sailors will survive. Because he did his job right. Captain Jocko Clark, April 15, 1943. USS Yorktown commissioning ceremony. Captain Clark stands on the flight deck surrounded by his crew and shipyard workers. Hess driven these people hard, demanded the impossible. Met resistance with determination. Bent rules. Broken rules. Made enemies. But the ship is ready. On schedule, against all predictions. He looks at the faces around him. Sailors in dress uniforms, shipyard workers in work clothes. Some resent him. Many respect him. All of them contributed to this moment. Get things done yesterday, Head told them. Tomorrow may be too late. They got it done. In 3 months, Yorktown will arrive at Pearl Harbor. In 6 months, Shell be in combat. Shell survive the war, serve with distinction, earn 11 battle stars. 25 years later, Clark will retire as a 4-star admiral. But hell always remember this day. This ship. These people. Homer Ferguson, president of Newport News Shipbuilding. Later, Rear Admiral Ferguson put in charge of all Navy production. He walks through his yard in 1943 seeing 9 Essex-class carriers in various stages of construction. 9. His yard is building 9 fleet carriers simultaneously. Before the war, this would have been unimaginable. He thinks about the workers, 30,000 of them. The apprentices learning their trades, the experienced craftsmen passing on knowledge, the women proving they can do the work, the African Americans in the hardest jobs. He thinks about the challenges, material shortages, labor disputes, design changes, impossible schedules. But mostly he thinks about the ships. 9 carriers. Each one capable of projecting American power across the Pacific. Each one carrying 96 aircraft and 600 sailors. Each one representing millions of hours of skilled work. His yard is doing this. His workers are doing this. He feels pride, and responsibility, and determination to keep going. Because the war isn't over. The fleet needs more ships. And Newport News will deliver them. The apprentice Hess, 17, from a farm in rural Virginia. 6 months ago, had never seen the ocean. Never seen a ship. Never held a machinist's tool. Now Hez in the machine shop at Newport News learning to operate a lathe that's producing components for carrier propulsion systems. The tolerances are measured in thousandths of an inch. The component must be perfect or the turbine won't work properly. His instructor, a machinist with 40 years experience, watches over his shoulder. Steady, the old man says. Don't rush. Feel the machine. Listen to the cut. The apprentice adjusts his grip. Focuses. The lathe removes metal with precision. The component takes shape. After 4 years of training, he'll be a journeyman machinist. But Hez learning faster now. War accelerates everything. He doesn't think about naval strategy or industrial capacity or geopolitics. He thinks about this component, this cut, this measurement. Get it right. Make it perfect. The ship depends on it. Small decisions multiplied across thousands of workers become victory. The cost. Not everyone survives. Industrial accidents kill workers. A crane operator loses focus for 1 second. A load shifts cables, snaps, someone dies. A welder working in a confined space is overcome by fumes. By the time help arrives, it's too late. A worker slips on a wet deck, falls from scaffolding, breaks his neck. The war kills American workers even in shipyards thousands of miles from combat. Families receive telegrams, funerals are held, work continues. Because it must. Because ships must be built. Because the war must be won. The human cost of naval construction rarely appears in histories. But it's real. People sacrificed, not just sailors in combat, but workers on the home front. They deserve to be remembered too. September 2nd, 1945. The surrender ceremony concludes. Japanese representatives return to shore. The war is officially over. In the celebration that follows, in the relief and joy of peace, certain lessons seem obvious. Lesson 1. Industrial capacity is decisive in modern war. This lesson appears self-evident. America's factories, shipyards, and farms produced the tools of victory. Superior production overwhelmed enemy quality. Military planners in 1945 believe this lesson will never be forgotten. Lesson 2. Workforce expertise takes decades to develop. The skilled workers who built the fleet, the foremen with 30 years' experience, the craftsmen who understood ships intimately, were invaluable. You can't create that expertise overnight. Planners in 1945 believe America will maintain its shipyard infrastructure. But history has a way of teaching lessons that are then forgotten. 70 years later, by 2015, American shipbuilding has largely collapsed. The commercial shipbuilding industry is effectively gone, unable to compete with foreign yards. Naval shipbuilding continues, but at much reduced scale. China has become the world's dominant shipbuilder. In 2023, China's shipyards produce more tonnage than the rest of the world combined. Their commercial shipbuilding industry is massive, their naval construction accelerating. The parallels to 1941 are uncomfortable. Then Japan assumed America couldn't build ships quickly. Now America assumes it can rebuild shipbuilding capacity if needed. Then skilled workforce took decades to develop. Now American shipyard workforce is aging. Few young workers entering the industry. Then government investment enabled rapid expansion. Now shipyard infrastructure is deteriorating. The lessons learned in 1945 have been largely forgotten by 2025. But Japan learned. Post-war Japan, rebuilt with American assistance, becomes a shipbuilding powerhouse. By the 1970s and 1980s, Japanese yards dominate commercial shipbuilding. The nation that couldn't match American production in World War II learns to build ships more efficiently than anyone else. They learned the lesson America forgot: maritime nations need robust shipbuilding industries. The irony: in 1941, Japanese admirals mocked American shipyards. In 1945, American shipyards proved decisive. In 2025, American shipbuilding has declined while Asian yards dominate. History doesn't repeat, but it rhymes. What 1945 teaches 2025. The lessons from World War II shipbuilding remain relevant. Industrial capacity matters. In a prolonged conflict, the ability to build and replace equipment is as important as the quality of individual weapons. Expertise takes time to develop. Skilled workers can't be created quickly. Apprenticeship and long-term employment build the expertise needed for complex construction. Infrastructure enables rapid response. Shipyards, machine tools, cranes, dry docks, these take years to build. Having them in place before crisis allows rapid expansion during crisis. Organization multiplies effectiveness. The American system of coordinated batch production, lead yards, and subcontractor networks achieved more than individual yards could have accomplished separately. Government investment is essential. Private industry won't maintain excess capacity for hypothetical wars. Government must invest to ensure capability exists when needed. Cultural adaptability matters. American willingness to change, to learn from combat, to modify designs during construction, provided advantages over more rigid opponents. These lessons were learned at great cost in World War II. They remain true today. Whether modern America remembers them is an open question. September 2nd, 1945. Tokyo Bay. One final time. The unnamed Japanese admiral watches Missouri's deck from Nagato's anchorage. The surrender ceremony is complete. The documents are signed. The war is over. He thinks back to the beginning. December 7th, 1941. Pearl Harbor burning. Celebration in Tokyo. The confident predictions. Americans can't build ships fast enough to matter. He thinks about the reports that followed. The carrier sightings multiplying. The intelligence assessments that seemed impossible. The growing realization that American shipyards were achieving what Japanese planners thought impossible. One carrier arriving at Pearl Harbor, then another, then several per month. The flood of American steel that drowned Japanese resistance. He thinks about Yamamoto's warning dismissed by so many. Yamamoto, who understood American industrial capacity. But even Yamamoto didn't fully grasp what American shipyards could accomplish. Detroit factories. Texas oil. These Yamamoto mentioned. But not the shipyards. Not Newport News and Brooklyn and Fore River and Philadelphia and Bath and all the others. Not the workers who made it happen. The welders and riveters and machinists and crane operators and foremen and engineers and managers. Not the system that coordinated it all. The batch production, the specialization, the government investment, the subcontractor networks. 3 years ago, Japanese admirals laughed at American shipyards. The admiral looks across the water at Missouri, at the carriers on the horizon, at the cruisers, destroyers, submarines, auxiliaries, an entire fleet built since Pearl Harbor. The laughter seems very distant now, a relic of a time when Japan's leaders misunderstood their enemy, when confidence blinded them to reality, when cultural assumptions led them to catastrophic miscalculation. The American shipyards had the last word, and that word was written in steel across the Pacific.